Hello, welcome to part 2 of Edexcel Paper 1, Physics. Let's look at the next question and following on from the other video. So we'll start quite quickly. So number 2, the student investigates what happens when light travels from air to glass. We need to read that carefully, from air to glass. Figure 2 shows some of the apparatus used in the investigation. Okay, the ray box. The ray, they're drawing a ray of light and they're drawing the arrows as you should do, the direction it's going in. Glass block. So this is the glass block here and the outside is air. They've drawn a normal. So remember a normal line is a line drawn at right angles or perpendicular to the surface of the glass block or the medium that your light is entering in. Okay, so let's have a look. So figure 2 is this whole figure. Angle Y, okay, this angle, we need to be careful when we don't look at that one. Y is the angle of, okay, that's what's happening here. So when light goes into a different medium and speeds up or slows down, remember it is refraction. That makes it quite easy for us to pick the right answer here. Okay, so we don't talk about clinical deflection. Incidence, the angle of incidence is where it's going in. Reflection is not happening here. It's not bouncing off. So it's refraction. Remember, we have to mark the box clearly with our pen, like that. That's how we mark it. Okay, there's only one answer, very straightforward. We might have to refer back to the diagram. So figure 3 is a graph, this one, of the student's results. Okay. Use the graph to calculate a value for angle Y over angle X. Okay, that sounds harder than it is, but all it is reading things from the graph. So let's pick a point, an easier point from the graph. So let's have a look. You can even pick this one. Okay, maybe we'll pick that one. That's on 20. So let's write angle X. Write it over here, 20. Okay, let's have a look then for Y. Let's make this Y a bit clearer. It's a Y. So let's have a look where that is in the graph. Okay, so it's here, right? So that's 15. So 15, and that's 10. So if we go to 11, 12, what? Okay, so it's just going up in ones. Okay, so we'll be checking the axes at the what it goes up in. So 10, 11, 12, okay, 13, 14. So that's actually at 13. Okay, so you always be careful with that. The axes, so 20 and 13. So let's have a look. So angle Y, let's think what to do with these numbers. So angle Y is 13 over 20. So all you're doing is a value. So you're just putting those numbers into a calculator. So if we put 13 divided by 20 into a calculator, you always allow a calculator, get 0.65. Okay. And we're going to write the answer where suggested, 0.65. Okay, that's all you have to do for that. Okay, so that looks worse than it is. That we're just reading from a graph. The student concludes that angle Y is directly proportional to angle X. Okay, so it does look like it is. It's going in a straight line so far. Okay, so directly proportional means as one goes up, the other value goes up. So directly proportional, as the value of X increases, the value of Y increases, or as the value of Y decreases, the value of X decreases. So they do the same thing, directly proportional. Explain what the student must do to test this conclusion in more detail. Okay, so this is a very actually easy question, really, because we didn't even really need to do any sort of science when you're here. You just need to know about experiments. So repeat. So again, they haven't got many results there. They've only got 2 data points. So repeat, they'll give you 1 mark saying that the experiment, okay, you want to write a nice full sentence, okay, with, this will give you the other marks, with more values, okay, of X and larger values, because we've only got small up to 20 there, wasn't it? So larger values of X. We want to continue, see if that line continues. Okay, we want to see if that line continues. So larger values of X. That will give you 3 marks. Okay. Let's look at the next one. We've got an equation. Speed of light is 3 times 10 to the power of 8 meters per second. That's the speed of light in a vacuum. The wavelength of yellow light is 5.8 times 10 to the minus 7 meters. Calculate the frequency of yellow light. Okay, we've told the frequency, state the unit, and use it. We've been given it. We even need to look for the equation. Okay, this is worth 3 marks. It's actually a nice question to do. So all we have to do is put in numbers. Okay, I'm just going to write the equation out and put the numbers in. So frequency, we don't know. That's what we need to find. So speed, 3 times 10 to the power of 8 meters per second, units of speed. Same units of speed as for light as everything else. And the wavelength, okay, it's already in meters. We don't even have to convert that. 5.8 times 10 to the minus 7 meters. All we have to do is to put that into the calculator. We don't need to do anything else. So when we put that into a calculator, we get 5.2 times 10 to the power of 14, and the unit of frequency is hertz, Hz. Okay, that was another mark there, isn't it? Is remembering the unit. So let's write the answer in. 5.2 times 10 to the 14, and then the unit gives us another mark, Hz, big H, small z, hertz. That is all we had to do for that question. Okay, that's really nice and straightforward, that one. Some blank pages. Okay, radiation, one of my favourite bits. Very interesting. Figure 4 shows a Geiger Muller tube. So this bit is a Geiger Muller tube, this bit here, used for measuring radioactivity. Okay, describe how a teacher should use the Geiger Muller tube, let's call it a GM tube, instead of saying that it's 2 people's names there, to compare the count rates from 2 different radioactive rocks. Okay, yep, some rocks are radioactive. So this is actually, again, a nice simple question for 4 marks. So let's do some steps. Okay. So they count rates from 2 different radioactive rocks. There's 2 different rocks. That's the only thing to note here. There's 2 rocks, not just 1. Okay. So put rock 1. Okay, or 1 rock 1, if you're labeled it rock 1, in front of GM tube. Okay, it doesn't go inside it or anything, it goes in front of it. Tube. So tube. I already wrote GM. So it's kind of like here. It goes in front of here. You can put it about there. Okay. Okay, number 2. Gives me a little bit of space. Okay, so measure the count rate. Okay, measure the count rate of what rock 1. That'll be on the counter. It's connected to a counter. That's that big box. Measure the count rate. I was saying counter. Measuring the, you could say counter measurement. That would have been okay. Count rate of, yeah, it's okay. If you make a mistake, just cross it out like that. That's absolutely fine. The person can see you cross that out. So that's a good thing. If you make a mistake, just cross through like that. Don't spend too long. Like, as long as they know you cross through it. Measure the count rate of rock 1. Okay. So you measure the, so you can actually set the counter to measure the count rate, or you can actually measure how many counts and divide it by time. Okay, there's two things. You can either measure the count rate directly, okay, or we can measure, so I'm going to write that as brackets, but okay, or measure count and divide, measure count for, say, example, 1 minute, count, I'm going to say 60 seconds, the same as 1 minute, for 60 seconds, that's seconds, sorry, seconds, and divide by 60, so you get per second then. You get marks for saying both those things, either of those things. Okay, right, just showing there is an alternative there. Okay, and repeat for rock 2 on its own. Okay, there's now an extra thing you need to do. So you take into account the background. So there's 4 marks because you need to take into account the background. But before we do that, let me just write that for 5. Okay, so for 4, okay, so repeat this measurement 3 times for each rock. You might have an anomaly. 3 times for each rock. So repeating the experiment. Okay. And then take background radiation away from measurements. So if you remember, background radiation is when there isn't anything in front of the Geiger counter. So what you do is leave that, say example, just by itself, no radioactive rocks or anything near it for say 5 minutes, and measure the background. Okay, so just as long as you can measure it for the background to get the best result you can. So if you need to look up and revise what background radiation is, so it's the radiation that's around us. So when you take a measurement, you always need to account for that background radiation. Okay, that'll give you 4 marks. I've written 5 things, but it'll give you 4 marks. So that will make sure to get you the 4 marks there. Okay. Okay, let's look at the next question. A hospital uses a radioactive isotope with a half-life of 6 hours. A technician measures a count rate of 80 counts per minute. Okay, so it's per minute this time from this isotope. Count rate in counts per minute, CPM, time in hours. Complete the graph of figure 5 as accurately as possible to show how the count rate from this isotope will change from the time of first measurement. The first point is already drawn in figure 5. Okay, it's very subtle, it's there, so 80. Okay, so 80, so count rate in counts per minute, and that we need to know its half-life. Okay, so it's got a half-life of 6 hours. That means every 6 hours, it goes down by half. So let's look. So this is divided up. So 5, that's 6, 7. Let's see how that's divided up. Always be careful of the axes. 5, 6, 7, 8, 9. Okay, so yeah, that's every 2 squares is 1 hour. Okay, so be careful of that. So one half-life in the case of this isotope, every isotope's different, so we'll be told what it is, or be able to we can work out, we want to remember certain things like that. So 6 hours, that's 6 hours, going up from 6, it will be down to 40, because 40 is half of 80. Okay, so we need to go through another half-life. So another 6 hours, so that'll be a total of 12. So that's 11, that's 12. Okay, so we're going to go up. Okay, and so we're going to go up to 20. So we're going to go up there. Because half of 40 is 20. Okay, and you get the characteristic graph going on. Let's see if we can go for another half-life. So that'll be 18, 12 plus 6. 15, 16, 17, 18, 18 and 10. Okay, So let's check that again. So we'll check 16, 17, 18. Yeah, that's fine. Okay, that's what that looks like. And then you draw as best as you can. Okay, even if you have to sort of do it in 2 bits, a curved line. It's not a straight line. You've got to show a curved line like that through it. Okay. And go through all the points. That will give you 3 marks. So that graph will definitely give you 3 marks. So I'm going to stop there for part 2, and I'll see you in part 3. So thank you, and I'll see you in part 3.